Welcome to section 4.1, exponents as integers. So, first off, let's talk about what is an exponent and what it looks like. Exponents are the smaller number that's always at the top right of a base, or just a regular variable, or just a number. So here is an example where I label that the x is the base, meaning the regular size number or regular size variable, where you have a smaller number or a smaller variable that is called as exponent. So again, when I'm referring to the base, I'm referring to this right here. And then here are a, which represent any given number or any given variable that's located at the top right, is called an exponent. So be mindful when I'm referring to as bases or as exponents. Now, what I wrote here are the laws of exponents. Make sure you have this in your notes because we're going to be referring back to them, using them, or maybe me going back to them, the laws of exponents that we're going to use to apply in the following examples. So let's start off with the laws of exponents. The first one right here, when you have two same bases, in this case, our x's are the bases, our exponent is a and our exponent is b. When the two bases are multiplying, so my key phrase is when the two same bases right here are multiplying, then simply it's going to be simplified into x to the power of a plus b. What it means from here is that you're just going to simply add the exponents together and you write the base one time. But again, if it's the same base that are multiplying, you add the exponents together. That's all you have to do. Don't confuse with, oh, I'm just going to multiply the exponents because the bases are the same. That's not true. It doesn't work that way. It is mathematically incorrect. If you were to multiply the exponents, you will get a different answer and it won't match with the law of exponents. So, to review, when same bases are multiplying, it just means that you're going to add the exponents together. So, think of this. Same bases multiplying, add exponents. Now the opposite can be the same. So here, same bases, which is in fraction form, it means divide. So, if same bases are dividing, then that means I'm going to be subtracting the exponent. So when I simplify, my top exponent will come first, then minus, and then the exponents in the denominator will be the second one. So a minus b. So my a is on the top, it will come first. And then minus, my b is in the bottom, b will come second. So when it's same base that is dividing, you're going to subtract exponents top minus bottom. So again, when same bases are dividing, it's top exponent minus bottom exponent. And the third law of exponent, when it's x to the power a being raised by another exponent, just like this, meaning if you have an exponent outside the parenthesis, that means you're actually going to multiply the exponent. So this is the only case where you multiply exponents. It's when you have an exponent on the outside of the parenthesis and you have the exponent on the inside of the parenthesis. So you're going to distribute, or you're just simply going to multiply the exponents together. You're not doing anything to the base, just simply multiplying the exponent together. Now, let's talk about when you have negative exponents. So in any event you have negative exponents, like this one right here. So be mindful that you're not going to have questions in this form. What's different is that I added parentheses because I want to emphasize that the negative a is an exponent. So right now it says that x is being raised to the negative a power. So what it means is that in order to have it in positive exponents, because what they don't tell you is that at the end of the problem, when you're working with exponents, you always want to have your final answer with positive exponents. So I repeat, when you're working with exponents, your final answer should always have positive exponents. Never negative exponents, positive exponents. So if you were to simplify, at the moment, x is on the top. So it's like whole number. When you're trying to convert it into a fraction, you always put 1 underneath, like this. Now, in order to convert a positive exponent to be positive, you always move it to the opposite side. So right now, my x to the negative a is in the numerator on the top. To convert it into a positive exponent, you move it to the opposite side, which is to the bottom. So we move x to the negative a to the bottom, to the denominator, and that became a positive exponent now. I wrote an example here. On the numerator, the top, is x to the a power times y to the negative b power over z to the c power. To simplify the negative exponent, all we did was just simply move the y to the denominator and then change negative b into positive b. So if you look over here, when we move the y from the top to the bottom, it's only x to the a power in the numerator, and in the denominator, the bottom, now it's y to the positive b power times z to the c power. So again, to go from this to this, the only change was moving the y to the opposite side, so from top to bottom. And then when that happens, when you move it to the opposite side, my negative b exponent became positive b. The same thing can be said if it was in the denominator. So over here, I added this little note that you should have in your notes to remember. When you have a base with a negative exponent in the denominator, to change it to positive, you're just going to move it to the top. So x to the a is the same thing as x to the a over 1. We simply move x to the power of negative a to the top, move it to the opposite side, which is top, and then change into a positive a. So I wrote a little example here. So we have x to the a power over y to the b power times z to the negative c power. Since I want z to have a positive exponent, I'm simply going to move it to the opposite side. So from bottom to top, which I did over here, and I converted negative c into positive c. So to review, when you want to convert a negative exponent into positive exponent, simply move it to the opposite side. So meaning, if it's at the top, move it to the bottom. If it's at the bottom, move it to the top. And then after you do that, you can convert it into a positive exponent and then work from there.